everyone. So my name is Kannaganti Bhargav Kumar. I'm a PhD student in Indian Institute of Science, Bangalore. So I am currently working on a riverine floods. So my main research interest is to understand how the climate change and human interventions affected the flood frequency and intensity. So I'm working on whole India scale. With major focus on Krishna Basin and Mahanadi and Kaveri basins. So this is about my PhD. So I completed my master's from IIT Guwahati in same water resource engineering. And I attempted GATE 2 times. One is in 2015, one was in 2015, and another was in 2018. Both the times I did the self preparation only and secured good score, which is quite good, I feel. So and I did my BTech in civil engineering from Visakhapatnam. Am I audible now, Jitendra? Can anybody confirm? Are you able to hear me?
Yes, sir.
Okay. Whatever yeah. So far, are you like? Did you heard what I told?
Yes,
Like
sir.
about my education, other things. So shall I repeat it again?
Sir, it was
You can type here if. Dipti, did you heard what I told?
yes, sir.
Okay, so I did my BTech from in civil engineering from Visakhapatnam. That was in 2015 I completed. So I was a lateral entry student, not a regular student. So right after 10th I did my polytechnic and I joined for BTech second year. Okay, that is the whole history. Yeah, let's come to this PMRF fellowship. After I joined for PhD in IISc Bangalore, that in 2019. So I did first year is full of coursework. So I did coursework and all. In the second year, I got to know about this particular opportunity called Prime Minister Research Fellowship. And in that particular program, there is another channel called a lateral entry program. So the current any student from IISc and IITs are eligible to apply, provided they have a good CGPA. So I met the conditions and I applied for the PMRF and I secured the PMRF fellowship in 2020. So this is my third year PMRF fellowship. So under this particular fellowship, I receive monthly stipend of 75,000 and with additional grant of 2 lakh per year. That is, and as well as a social service, I need to conduct at least one lecture per a week to either graduate level or an graduate level or undergraduate level. So with this motto, I approached the NPTEL and they provided me this opportunity to interact with you. So that is my background. So I'll call one by one. If you feel like to keep your video on, you can keep. Otherwise, you can say normally also. So I'll go with the names, what I can see here. So first, Anjali. So we are doing here the just introduction. You can say your name, current education. Are you like whether you're completed BTech or pursuing? Did you attempted GATE before or not? These are the broader things you can say. Anjali.
Yes, sir. Good evening.
Good evening. So you completed BTech?
No, sir. I am in a third semester of BTech.
Third semester. Okay, good. So what is your planning? Like, what do you want to do after BTech?
सर आफ्टर बीटेक मैं गवर्नमेंट एग्जाम के लिए मतलब प्रिपरेशन अभी कर रही हूँ.
Good, good. I hope these sessions will help you. Thank you. Thanks for joining.
Okay, sir.
Deepti.
Good evening, sir.
Good evening. Deepti, can you speak a little bit loud?
Okay. Sir, am I audible now?
Yes, yes. Good, perfect.
Sir, I have completed my MTech, my master's in environmental engineering, and I did my BTech in civil engineering from Petroleum University. And right now I'm preparing for GATE self preparation. And earlier also I have given GATE exam in 2022. I secured rank 899, which was not a good rank, but I was trying on my own. So I'm hoping that this year I will get a good rank.
Yeah, definitely will get. All the best. Thanks for
Thank you,
joining.
sir.
Yeah, Jitendra.
Hello,
Hi, Jitendra.
good evening, sir. I
Good.
am pursuing my master degree in physics from Jain and Vyas University, Jodhpur.
Good.
This is my first attempt.
Okay, good. So I hope these sessions will help you. Thanks for joining.
Thank you, sir.
Gautam. Hey, Gautam.
Good afternoon, sir.
Good afternoon.
I have completed the civil engineering. This is my first attempt in GATE.
So you are a fresh graduate, like 20, like when did you completed a BTech?
2021, sir. B.
Sorry, BE. When did you completed BA?
2021 civil engineering.
2021. Good, good. So this is your first attempt.
Yeah, sir.
Good. All the best, and I hope these sessions will help you. Thanks for joining.
Okay, thank you, sir.
Kagita Hema. You can just briefly introduce yourself, like, yeah.
Good evening, sir.
Good evening, Hema.
Sir, myself is Kite Hema, sir.
Okay.
I'm studying in BTech third year, sir.
Good. So this will be your first attempt.
Yes, sir.
All the best, and I hope these sessions will help you. Thanks for joining.
Thank you, sir.
Yeah, Mitali Gohil. Pardon me if I pronounce your name wrongly.
No, sir, you pronounce it very clearly.
Yeah,
Good
thanks.
evening, sir. Good
Good
evening,
evening.
sir. Myself, Mitali Gohil, and I did my graduation in civil engineering. And currently, I'm pursuing masters in hydraulic structure from Maharaja Sayajirao University, Vadodara, Gujarat. And this is my first attempt.
All the very best, and thanks for joining.
You're welcome, sir.
Yeah, Mithun. Hello, Mithun, are you there? Okay. Prashant.
Good afternoon, sir.
Good
Good
afternoon.
evening, sir. Myself Prashant. I'm currently doing my BTech civil engineering third year from
Okay.
Chennai in Assistant College of Engineering.
Okay. So this will be your first attempt.
Yes, sir.
Good. Thanks. Thanks for joining, and these sessions will surely help you. Please do join for the next sessions also. Yeah, Mithun, please introduce about yourself.
Yes, sir. I am from. I finished my fourth year civil engineering BTech.
Okay. So this is your first attempt, or did you attempt it before?
No, sir, this is my first attempt.
Okay, good. So thanks for joining. So all the very best for your GATE exam.
Thank you,
Okay.
sir.
So it's already 6:04. So I think we'll start. And please kindly mute yourself for the rest of the session. And whenever you have a doubt, you can just like you can stop me and ask. I'll explain it neatly. So please allow me to join again via iPad, because I'm going to write few things on PPT. Okay. Others, kindly mute your video. Sorry for the glitch. Uh, I'll share my screen. Yeah. Can anybody confirm you can able to see my slides here?
Yes, sir.
Thanks.
Yes, sir.
Thanks.
Yes, sir.
Thank you very much. So let's start the session. So the slide is clearly visible for you, na?
Yes, sir.
Yes, sir.
Thanks very much. So this is a phase 2 for the NPTEL live interaction session. This is a session 1. So as I mentioned, my name is Kannaganti Bhargav Kumar. I'm a PhD student in Indian Institute of Science, Bangalore. So in the website, we have mentioned the today's topic also. So today we are discussing about specific energy curve as well as a critical flow. So, and followed by two numericals, two previous gate numericals, 2 marks questions. Okay, I hope this session will help you. Okay, let's get started. So I have taken all the material from Wendy Chow book, so you can refer. I can provide the reference for you in the chat box at the end of the session. Okay. Suppose like we have the open channel like this. So this is a water level, and this is a channel bottom, and this is a depth of water y, and I have considered datum somewhere here z. This is a datum. Please alert me if the font is too small also. Okay. Suppose let's say if I want to know what is the total energy at any point in this particular channel. So as we know from the fluid mechanics in the semester 2, the total energy is a sum of datum energy, datum energy plus potential energy plus kinetic energy. Suppose if you look at the general equation here, let's say this is a total energy equation, and this particular term represents the datum energy, and this d cos theta represents the potential energy, and alpha v square 2 divided by 2g represents the kinetic energy. Okay. Now this is a general equation for the total energy, but this is not of our interest in the open channel flow, because in in the open channel flow we always look at the profile, how the profile will vary along the flow direction. Suppose if you look at the total energy profile, suppose if I calculate the total energy at this particular section 1 and at section 2 always this the along the flow direction the total energy will decrease, but specific energy according to the flow condition it may remain same, and it will either decrease and increase. And specific energy is more critical when it comes to the open channel flow, where total energy is more critical when it comes to the fluid flow in pipes. So today we will see what is the specific energy. So specific energy is nothing but energy per kg of water at any section in a channel. Suppose let's say this is section 1 I want to know what is the energy available with the water at this particular section per kg of water with respect to the channel bottom only. I don't want energy from the datum section. I want only from the channel bottom. Okay. So what is the energy per kg of water at any section of a channel with respect to the channel bottom? So that will directly give us y plus q square divided by 2g a square, where q is the discharge, a is the area, g is acceleration due to gravity, y is the flow depth. See, you might have seen, yes. So you might have seen this formula in this format, y plus v square by 2g. So this is a formula of specific energy. But yeah, but as we know, so can you mute yourself? Gagan, kindly mute yourself. Yeah. See, I one more warning. Please kindly mute yourself during the lecture, because others may feel discomfort. Okay. Thanks, sir. Okay. So as we are where we are, so specific energy nothing but energy per kg of water at any section of a channel with respect to the channel bottom. That is a definition for specific energy. And in the textbooks, you may have seen the formula in this format: E equal to y plus v square by 2g, where v square by 2g is kinetic energy, or nothing but we can even call as kinetic head, and where y is datum potential head, E is the total specific energy per kg of water. Okay. So what are the assumptions we made to derive this particular specific energy? First assumption is that potential energy is zero. What we do mean by here? which means that Z equal to 0. So from the total energy equation, which is this one, we neglected the datum energy component, which we made it as a 0, and as well as channel slope is small. Here if you see d into cos theta, okay, we assume that the theta will be very small. That's why we neglected. So we assume that channel slope is small. So you know that cos 0 is equal to 1. Suppose the value is small, then cos theta will be equal to 1. Okay, so approximately will be equal to 1, as well as momentum factor is equal to 1. This alpha here represents the kinetic moment factor. We assume that this is equal to 1. So we, after assuming this following three, we arrived this particular equation. So this is nothing but specific energy equation, which is equal to E equal to y plus q square by 2g into a square. See, why I have written this particular formula in discharge terms, that you will get to know what is the advantage of writing this particular formula in discharge term rather than the velocity terms. Okay, if you look at this particular equation, let's say we for a given channel section and for a given discharge, the specific energy in a channel is only a function of depth. Suppose you know a equal to b into y. Okay, and for a given channel section and discharge, the specific energy in a channel is only a function of depth. Suppose let's say if I want to see how the specific energy is varying with respect to y, which means the depth. So what I can do is that I can plot a diagram between the specific energy as well as the depth. So let's see more clearly here. So this particular curve is called specific energy curve. This is a very important curve in open channel flow. With the help of this particular curve only, we'll solve almost all the questions. Okay. So what exactly this particular graph contain? If you look at here, the x-axis represents the specific energy and y-axis represents the flow depth. Okay, and here this dark black color is the curve, which has two limbs. One is AC, another is a BC. Okay, and it has another 45 degrees line, 0 to D. Okay, suppose if you look at this particular point, what we can interpret from this particular curve. Suppose let's say if I take any point P, let's say if I take any point P here on the curve, what it represents. Suppose let's say if I take any point P on curve, it gives, okay, if you look at here, y even I can zoom in. Can you able to see here now? Okay, if I take point P here, it contains two component, y plus v square by 2g both. Okay, that so, and suppose if you narrow it down here, that is E, which is sum of y plus v square by 2g, and correspondingly we will have a depth which is equal to y. Okay, and additionally if you look at more clearly this particular graph, okay, suppose let's say this is a one line we have drawn. For any given E, we are observing two depth. One is y1, another is y2. Okay, so what are these two depths called? So these two depths are called alternative depths. This is very important for a IAS exam. Okay, suppose if I take E1 here, this particular E1 is showing a two depths, y1 and y2, for a same specific energy. It is called alternative depths. So there is another similar term called sequent depths. I think most of you know, the sequence depths will have a same specific force, whereas alternative depths will have same specific energy. Okay, whereas sequence depths. Okay. Suppose, so these particular curve are drawn for a given channel for a given discharge. Let's say if the in the particular channel we have another q value. Suppose let's say if the q is greater than q, then the curve will shift to the right. If the q is smaller than the q, new q, then the curve will shift leftward. So this particular understanding will help you in solving the questions on channel transition, where they'll ask the question that, suppose let's say if I raise the bed by a z height, then what will happen to the flow depth? So these kind of questions will you may see in the gate exam, like a flow over a hump. Suppose if I do the decrease the width of the channel, what will happen to the flow at the top of the hump, or at the channel transition? All these kind of questions you might have seen. So to solve those questions, the clear understanding of the specific energy curve is required. Suppose let's say if the flow is more than the given flow, then the curve shift to the right. And if you observe this y2, suppose let's see if I y2, and one more thing you can observe here, the point C is nothing but the critical flow condition, and which divides the flow state. Okay, whether the flow is a subcritical or supercritical. Suppose let's say if the flow is in subcritical state, if the discharge is more than this given discharge, the flow over the hump depth will increase. Okay, flow over the hump depth will increase. So these kind of questions we will solve in the next sessions. So there again I'll use the same graph, and we can interpret how exactly we are answering this particular question. So this alone this graph will suffice to solve all kind of questions with respect to the open channel flow. So I urge to go through this particular graph thoroughly and read what are the terms are, involved in the particular graph, what each line is represent. Okay, so the the overall funda is that a plot drawn between the flow depth versus specific energy is nothing but the specific energy curve, and this specific energy curves contains two lines. One is a 45 degrees line, another is a specific energy curve. Okay, and for a same specific energy we will have two depths. Those are called alternative depths, which are y1 and y2, and these two will have a same specific energy. Okay, and we have another special condition that is called critical flow. Critical flow is nothing but a state of flow where the specific energy is minimum. So this particular definition is very important to solve the questions. Okay, and in a practical condition, this is a state where the flow stage changes from subcritical to the supercritical. Suppose if you were inserted a sluice gate or something, you lower the sluice gate. At certain point of time, the flow changes its state from subcritical to supercritical. That particular condition is called critical flow condition. Even in a practical situation, the critical flow is very important to understand the hydraulic jump, to understand the height of hump, how much height of hump we can keep without changing the flow at the upstream as well as the downstream. All these kind of practical implications are there with respect to the critical flow. Okay, so now let's solve what is actually critical flow condition. Critical flow condition is nothing but the state of flow where the specific energy is minimum. Okay, suppose as we know, specific energy is equal to y plus v square by 2g, or alternatively how we have written q square by 2g into a square. Now let's say if I solve, if I differentiate with respect to y, d divided by dy, it will become 1 plus q square by 2z is common. So d by dy equal to a square. Here in a, we know a is product of b into y. Let's say if I take here, if you say dA equal to t into dy, where the already dA contain a contain the depth formula. Suppose if we take a rectangular, then a equal to b into y. So indirectly we have a b here. Then the differentiate with respect to y of a will give as minus 1 by minus 2 by a cube. So I'll show how we have got this. D by d of a minus 2. Suppose d by d by dx of x power n. What is x power n? N into x into x minus 1. Na? Suppose in place of positive n, if I take the negative n, d by dx of x minus 1, it will become minus x. So minus n x power minus 1. This is a condition. These are the straightforward results from the mathematics. Suppose d by dx of x power n will be is equal to n into x power n minus 1. Suppose instead of positive n, if I have a negative n, it will become minus n x power minus n minus 1. Okay, this tightly we got. Now 2 to get cancelled, then it will become equal to q square by, as well as we have dA by dA also, gaq dA by dy. Okay, so from the slide 1 we have seen dA equal to t into dy. Okay, so as I mentioned that for a critical flow condition is equal to minimum or 0. So let's say equal to 0, then 1 minus q square t by g a cube. Then q square t by g a cube equal to 1. So this is the first result, and as well as a very important result for solving all the type of questions in fluid mechanics. See, in open channel flow. Now let's further simplify this thing. Okay. As we know, velocity is equal to q by a. So what I can do is that I can replace q square by a square then t, already in this one we have a t into y. If I square do the square root on both the sides, can you able to see what exactly we arrived at? Froude number. So the definition of the critical flow is nothing but when the Froude number is equal to 1, the flow condition is said to be a critical flow. Okay. So from here, from the specific energy, we arrive to the Froude number. This is a derivation. Okay. So this is the second result. So there is another important result. From the same equation we'll solve q square by t equal to ga cube equal to 1. So I hope you know this term called discharge per unit width, small q, which is equal to capital T. So what I can do is that q square into t g. Suppose if I expand this, t cube into y cube equal to y. Okay, q cancelled. So q square by t square into 1 by g y cube equal to 1. Okay, so this will become q square divided by gy cube, which is equal to 1. Now, if I want to see here, yc is a critical flow, yc cube equal to q square by 2z. And where yc equal to q square by g whole power 1 by 3. This is a very important result for solving the problems. Okay. Now the fourth important. Sorry, I don't have a space. Maybe I can solve here. As we know, again we'll go with the same q square by t equal to g at cube equal to 1. As we know, v equal to q by a. So v square t divided by g equal to 1 into a. Okay. So v square divided by a by t equal to 1. Suppose if I write v square by 2g, it will equal to y by 2. Sorry if I made it more messy here. From next time I'll take care. I'll use more slides here. Today I don't know. I thought one slide would be sufficient. Okay. So remember this result: v square by 2 is equal to y by 2. So as we know, e equal to y plus v square by 2g. If I replace with the yc by 2, then ec equal to yc plus yc by 2. Then it will become 3yc by 2. Okay. So this is another important result. And yc equal to 2/3 of ec. Where ec and yc, when I say cc, these are with respect to the critical. Okay. So I hope you remember the result. So the critical formula is this one only: q square by t divided by gpa cube, g power a cube. This is a critical formula. If you know this particular formula, you can derive all the formulas with respect to the critical flow. So let's solve one question from GATE 2010, 2 marks question. This is a question number 41. So this question is as follows. They have given the Froude number of the flow in a rectangular channel. So they mentioned directly is a rectangular channel of has a Froude number of 0.8 and a depth of flow is 1.5 meter. Now they have asked us to calculate the critical depth. So anybody can you try and give me the answer quickly? So I'll give the hint. Just now we solve. So use the same q square by t equal to ga cube equal to 1. From this relation only you can derive. You can directly solve this question. Maybe you need to do few steps, but you can able to solve this question. So you look at this question. What we know fr, which is 0.8, and we know what we know flow depth 1.5 meter. So how we can solve, and we know what is a Froude number equation also, g into y. We just know this derived here. Second equation number 2. So can you quickly say the answer, anybody? Okay, I'll give the steps how we can proceed. First step, use this particular equation and estimate the velocity. Okay, and we know the discharge per unit width formula, q equal to a into v. Na, suppose let's say if I bring this b this side, then it will become q into y into v for rectangular channel. Rectangular channel a equal to b into y. Na? Okay, this is second step. Once we know the second step, so we just now derived one relation with in terms of q as well as a yc, which is nothing but yc cube equal to q square by g. So where how I can get g equal to q square by g equal to 1 by 3. Use this formula as a third step. can able to arrive the solution. Now can you say the answer, anybody? Sorry, I went bit speed because my session, like I got only 1 hour session. In that 1 hour session only I need to cover 2 problems and concept and everything. Okay, I hope it is clear what I have covered. You can just guess it, or what is the answer, either option A or B or C and D.
C, sir.
Huh? Which
C,
one?
sir.
Sir, D.
Correct.
D.
Very
1.29
nice.
meter.
Very nice. Very nice. Very nice. I hope you have followed the same steps, na? 1, 2, 3.
Yes, sir.
Okay. Okay. Let's see the solution here. So what we have given? We have given the forward number 0.8 and depth of 1.5 meter. So as we know, forward number FR equal to V divided by root over GY. So from there we can move this root over GY this side, and we can get the velocity of flow here, which is 3.0 meter per second. Okay. And next what we can do, we can calculate the discharge per unit width Q, which is equal to V into Y. Okay, which is equal to 3.06 into 1.5. The answer comes out to be 4.6 meter cube per second per meter. Okay, because this is discharge per unit width. Unit width has a units of meter. So now from the minimum specific energy calculation or critical flow conditions, we derived this particular equation, which is on yc equal to q squared g divided by 1 power 3. So which is now we know q, we know g. So we substitute directly here, and we got the answer as 1.29 meter. This is the option D is the correct answer. Okay. Anybody have a doubts? You can stop me. I can clarify. See, the main funda you to remember is q square g t divided by g into a cube equal to 1. If you remember this particular equation, then you can able to solve all the type of questions with respect to the critical flow. Okay, and you can derive instantaneously. You can derive all the formulas. Okay. Is there any question so far? Any clarity required? This I used a very small space to derive all the equations, but I hope it is visible. I don't know. Next time I'll use a different color. Red is too bright here, I feel. I'll use a blue color next time. Okay. So this is our first question. Let's solve somewhat a different question from the same GATE 2010 only. This is also for 2 marks question. So before, like without solving also, you can even guess the answer. Most of you know this question, I feel. So this is a question number 40 from GATE 2010. The question is as follows: for a rectangular channel section, Group 1 lists the geometrical elements, and Group 2 gives the proportions of hydraulically efficient section. So basically, in Group 1 we have these parameters, and Group 2 has the corresponding formulas for a hydraulically efficient section. Now our job is to match the Group 1 and Group 2, where YE is the flow depth corresponding to hydraulically efficient section. So now what would be the correct answer here?
D, sir.
D.
D, sir.
D. Okay.
D.
Yes.
Oh. So anybody can just explain what is the hydraulically efficient section? You mean?
It delivers maximum discharge within economically, sir.
Okay. Correct. So when we say any channel section is hydraulically efficient, it means that it should deliver maximum discharge, and at the lining cost should be minimal. Okay, there are 2 conditions to be met. One is that the provided channel section should be able to deliver the maximum discharge, and the cost of lining should be minimum. Okay, So now let's see how we can derive this particular condition. Okay, a channel section is called as efficient if it can pass maximum discharge for a given cross sectional area and for a given resistance coefficient as well as a bottom slope. Here, major things we need to remember is that the area is constant, the resistance coefficient is constant, as well as the bottom slope is constant. Provided these three are constant, how we can able to deliver the maximum discharge? Okay, that is a major condition. So somebody say rather than rectangular, we can put a triangular. Somebody says circular, we can put, but that is not the thing. Here, provided this cross sectional area is constant, as well as resistance coefficient is given, as well as bottom slope is given. Provided these three are given, how one can maximize the discharge, and as well as how one can reduce the cost of construction for a given same discharge. Okay, let's look at this particular formula, Manning's formula. Q equal to 1 by n a into r power 2 by 3 sf power 1 by 2. Maybe you might have seen in this way, Q equal to a into v, where v equal to 1 by n r power 2 by 3 sf power 1 by 2. So always remember, this is not s naught, this is should be sf. Okay, that is a slope of flow line, not slope of a ground. Okay, here let's see what are the terms. Here n is a
ట్రై చేసి నీకు పెడతా కుదిరితే.
hello, kindly mute yourself. Who is Guru? Guru, kindly mute yourself. Okay, and where n is the Manning's roughness coefficient, r represents the hydraulic radius, sf is the slope of a flow. Okay, and where v is the velocity and a is the area of the channel, q is the discharge. Now let's say this is a Manning's equation we use for calculation of discharge. Okay, and in the channel state, if said it is hydraulic efficient, then the cross sectional area is constant, bottom slope is constant, and resistance coefficient is also constant. Then what then? Q is directly a function of hydraulic radius. What is the hydraulic radius? Which is a ratio of wetted area divided by the wetted perimeter. Okay. Wetted perimeter. Okay. Now it is mentioned that the cross sectional area is constant. Then to make R as max more, then what we need to do? We need to reduce the perimeter here. Okay, wetted perimeter. If we minimize the wetted perimeter, the R will increase. Proportionally, discharge will increase here. Okay, because Q is directly proportional to the R. If R increases, discharge will increase. So how R can increase? If we reduce the wetted perimeter, then R will increase. Okay, let's derive this, how we can reduce this P for a rectangular channel. Okay, so this is a rectangular channel. It has a B width and Y depth. This is flow depth. And suppose, let's say if I want to see the wetted perimeter, wetted area, which is equal to B into Y. See, the channel may have a whole depth, but that is not of our interest. We'll always only take the wetted depth. And what is the perimeter? Which is equal to B into 2 into Y. So now our job is to do this one. We need to minimize the perimeter, wetted perimeter. Okay, dp by dy. So okay, so now let's solve. So as we know, a equal to b into y. So what is b? B equal to a by y. Because we are doing with respect to y, we are differentiating with respect to y. So I wanted to bring all the terms with us in all the terms in y. So p equal to a by y plus 2y. Okay, dp by dy equal to what will become a by y square plus 2y. So I'll show how we got this one. Dy by dy equal to a by y. Okay. So A is a constant here because it is given here. So d by dy into y 1 by y. So if I write here this one, it will become y power 1 minus 1, which is nothing but minus 1 y power minus 1 into minus 1, sorry, minus of minus 1, then minus 1 into y power minus 2, which is equal to 1 by y power 2. Okay, so in this way we got this. Okay, already we have a here, so a minus a by y square. Okay, so now to make this channel particular hydraulically efficient, we should make this dp by dy equal to 0. And a by y square equal to 2y. Okay, this is a one condition. Okay, so, sorry, here it should be y 2y square. Okay, a equal to 2y square. This y will get cancelled. Sorry for my mistake. A equal to 2y. Okay, 2y square equal to 2y square. This is we know. But as for the rectangular channel, what is area? Which is equal to b into y. Okay, let's equate both the terms. Y get cancelled, so hence b equal to 2y. Okay, so we got one first equation equal to b into 2y. Second, a equal to 2 into y square. Now, what is the perimeter we can get? B plus 2y, na? Already we know b equal to 2y plus 2y. So p equal to 4y. Okay. So let's say if I want to get r, what is r? A by p. So what is a? 2y square divided by 4y. So y will get cancelled, 1 by 2. So it will be 1 by 2. So what are the final equation? B will be equal to 2y, area equal to 2y square, p equal to 4y, r equal to y by 2. These are the four conditions for hydraulically efficient section. So let's see the options. What are there? Okay, what is the perimeter we got? Perimeter we got 4y. So instead of y, we have ya. So perimeter will be 4ya. So where we have Q4, only these two options can be neglected because we have Q4 in only C and D. Okay, and where we have a top width, here B is a width, top width, which is equal to 2y, which is equal to 2y. So where we have a P3, we have in both options. Okay, we cannot neglect. Now we need to see another one. So what is the hydraulics radius R? R equal to A by P. Or we have another option also. Hydraulic depth D, which is equal to A by B. Okay. That is also we can calculate here. But anyway, since we calculate the R, which is equal to y by 2, even we can calculate this also, 2 is equal to y square into 2y. Same. Okay. So what we have? R1 and S2. So correct option is C, not D. Okay. Please correct yourself if you made any mistake. Okay. Is this clear?
Yes, sir.
Okay. That's all from my side for today. So sorry if I went a bit speed. From next session, I'll make sure that since this is a first class, so And I just experimented with iPad today, so that's why I scrambled a lot here. But the next time I'll make sure that I have enough space to solve all these derivations. Okay, so I'll give the crux of the today's talk. So we started with the specific energy curve. So in the specific energy curve, we discussed over what is the specific energy definition. So specific energy definition is nothing but energy per kg of water at any section of a channel with respect to the channel bottom. So we have seen what are the assumptions we made to derive the specific energy, and and as well as we have seen the what exactly the specific energy curve shows to us. So in the specific energy curve, we have seen there are two depths. One is y1 and another is y2, and these two depths have a same specific energy, and these two depths are called alternative depths. Okay, and we have another term called sequence depths in hydraulics, that is that will have same specific force. So this sequence depth we'll see in a hydraulic jump lecture that I may take in maybe next class or next class. In that class we'll see what is a hydraulic jump, how we can compute the sequence depth, what is the relation between the sequence depths and all. Okay, so for a time sake you can remember the definition. The sequence depths will have a same specific force, whereas alternative depths will have a same specific energy. Okay, and we went on to the critical flow condition results. So the main condition is what is the critical flow? Critical flow is a state of flow where the specific energy is minimum. As well as you can even also see in so many of the textbooks, they'll say critical flow will have a Froude number equal to 1. That is also another definition of the critical flow. When the Froude number is equal to 1, the flow is said to be the critical flow. Suppose if the flow is if the Froude number is more than 1, we can say the flow is a supercritical flow. If the Froude number is less than 1, we can say it is a subcritical flow. And we have seen we even derive the Froude number equation from this specific energy curve here. Okay, equation number 2, and we have derived one general condition for the critical flow, which is equal to q square by t divided by g into a cube, which is equal to 1, which is equal to 1. I If you remember this particular equation, you can able to solve all type of questions with respect to the critical flow here. Okay, and we went on to solve v square by 2 is equal to y by 2 relation, as well as yc equal to q square by g relation and all. Then we solved one question from two questions from GATE 2010. So this question is of 2 marks, and the question number is 41. And this question, our interest is to calculate the critical depth, and we have seen the steps. The first steps we calculate the velocity, and the second step we calculate the discharge per unit weight, and the third step we did the critical flow depth computation. And the next question was about hydraulically efficient section, and we have seen what do we mean by the hydraulically efficient section, and what conditions should we meet to become called as a hydraulic efficient section. And we even derived how we can calculate the flow channel parameters and all, and we choose the final answer as a C. So this is a summary of the class. I'll stop here. I'll take the questions if you have any. Please excuse me if I went a bit fasting today, because I got only 1 hour, so I need to cover a lot of more topic. In the next class, I'll make sure that I'll go a bit slow and spend more time on each line and all. Thanks for joining today. I'm happy to take questions if you have any. It need not to be. You can even ask other questions. It need not to be a technical question. See, this particular session aim is to encourage and help the GATE aspirants. Okay, even any doubts regarding the PSU, even the MTech positions also, I can help you in that. Okay, feel free to ask. I can fairly say that I have a pretty much experience with the GATE exam, because I wrote 2 times, one in 2015, another in 2018, and I think I went all the IITs for my MTech admission in 2015. Finally, I got in IIT Guwahati. For PhD also, I went for 3 IITs: IIT Kharagpur, Chennai, as well as IIC Bangalore. Finally, got IIC Bangalore. So I pretty much attended most of interviews in all the IITs. Even I can help you in the interview procedures as well. So you can approach me anytime. Even after the session, also you can approach me via mail. I'll drop the mail here. Uh, okay, and you can drop me a mail at any time. I can help you. Not only with the technical, even other questions or other doubts about the PSUs and all those things. I can help you. Uh, if you have any questions, you can ask me quickly. I can help. I can answer. So, any suggestions about my lecture also you can give. Whether it is too fast or too slow, or should I need to change anything? You can add.
So can you send the book details of Wenchi Chow?
Yes, I can share the PDF, but I don't know how I can share data. In this same chat only, I can add here. Just stay in line. Yes, I can. I'm trying to attach the PDF here only. Otherwise, I can provide the link from where you can download. This is a classical book for the hydraulics.
Sir, can you explain or say something about CSIR UGC NET examination, sir? After BTech.
Oh, see, that NET exam is for the aspirants who want to pursue career in a science background. Okay, not the engineering. I mean to say, science means like at science. Yeah, these recorded lectures will be available in the same PMRF website. You can go like in the NPTEL website. You can get the link for the recorded video. Yeah. So coming to your question, so after you attempt this NET exam, NET exam, they will call for the interviews in multiple IITs, but in a science only, not in IIS. Even ISSIR also you can attempt, you can join science, IAS or Bhopal or other places. But you typically will take a research career in science, either earth science or geological science or bioscience and all. If you're from a civil engineering background, but I'm not sure where you can enter into engineering with a NEET. So that is not sure. I'm not sure. But as far as my knowledge, because all my friends who attended an UGC NET exam, they joined for either BSc Science or MSc Science or PhD Science. Okay. So in IISc, we have a separate department called Earth Science Engineering. So in that Earth Science, all are listed civil engineers only. They gave the net UGC NET exam and they joined for Earth Science here. Okay.
I am looking for a career in neurosciences, sir. So will it be helpful for me to give CSIR UGC NET?
What is your BTech discipline?
Civil engineering, sir.
Civil engineering.
And I would like to go into neurosciences or cognitive psychology.
Yeah, that is a very nice area now. But see, in IISc we have a separate branches, two separate department we have here, neuroscience department as well as a brain research and other things. You can apply for this year, but you need to defend your discipline. Like why do you want to change from civil engineer to this particular branch? So that is the most difficult thing you need to defend. Other questions you may be able to answer, but they'll ask specifically why you want to switch from civil to neuroscience. That if you can able to just give the nice answer, then definitely they will take you. And
I
I'm
have
very much
also got to know that CU set exam also provides a way to get into this psychology or neurosciences branch, sir.
yes,
But
there are, see, all
how
these things
can
are
a
there.
civil engineering student get into that?
I'm not sure about that. I have no idea. Sorry.
We can
Yes,
write that exam, sir, or will BTech become any kind of problem to attempt that exams?
I'm not sure. What is your name? I forgot.
My name is Lakshmi Tejasvi, sir.
Lakshmi, I am not sure about that particular exam. I only know UGC, NET, and as well as this GATE exam. Okay.
Okay, sir.
Yeah, I'm providing
Thank you,
this
sir.
reference. I'm providing this open channel reference. Just being staying here only. I will upload in my OneDrive and share the link here. Meanwhile, you guys have any doubts? I'm trying to load this particular. Yes, you can use this link to download the textbook. Whoever is interested, and please feel free to approach me if you have any doubts. Yeah. So next session, as I mentioned in the syllabus, next session, please join. It is on the same Tuesday, 6 to 7. Okay. And have a good day.
Thank you, sir.
Thank you very much. Please do.